Configured. Hello. Hello, Chris.
Hello, everyone.
Hello, everyone. Hello, Chris. I'm super happy we are online. I didn't have a webinar yesterday about the GC internals, but at least today we have the webinar about the troubleshooting the GC issues. So say hello, say from where you are, and we are super happy that you are here today because we like GC and we like talking about GC, right? So let's just check whether we are really online and whether it seems we are. Okay, so today's topic is the troubleshooting GC issues, and we are having Christophe Nasarre. How I could spell it? Probably it is absolutely bad in French. So could you say it properly?
It's Christophe Nasarre. It's like Christophe Nasarre.
Sure.
Yeah.
Very easy.
Not really important.
Christophe Nasarre.
Yeah, Chris is nice.
So Chris is more easy to spell, at least.
Exactly, in most of the countries.
Maybe just a kind of introduction, Chris. Could you say, I don't know how many words you want to say about you?
Yeah, so I'm working at Criteo. It's a French company, and we are dealing with a large number of web application and with 6 or 7 data centers worldwide. And I'm in a team in charge of helping the application when problems start to ping, and I'm trying to share this kind of stories and experiences with you guys.
And you have some experience in troubleshooting, including GC issues, right?
Yes.
And by the way, you because of this experience and because you talk at conferences sharing knowledge about that, we invited you to be a mentor in our diagnostics expert course that I will mention about later on. But you are here to hear about GC and not about us, so maybe we can just start talking. And Chris, the scene is yours. If you could start to enlighten us about the GC.
Yeah. So we thought about having a kind of summary of possible issues around GC and trying to show you some real world experience that you could use in your daily job. So basically, the idea of an investigation is most of the time these 3 different steps. First, you try to identify where the problem could come from. So you need to look at some data, some metrics, and the most important part of that is that you need to trust what you are looking at. The second step is to understand the picture given by the metrics, and then guess problem causes. So you just emit an hypothesis based on what you know about the platform, the application, and what you know about the general framework that you are using that could explain the numbers that you are seeing. And the third step is to verify that hypothesis is right or wrong. If it's right, then you have a fix, and you put the fix in your testing environment and in production, and you validate that it's okay. If it's not the case, then you went a little bit deeper inside the infrastructure, and you need to go back to the first step again, look at different numbers, try to understand, and so on. So it's not really hard. I've heard people saying that debugging is kind of something artistic, or you guess, or it's definitely not the case. Yeah, kind of magic. You're right. You can think that it's part of magic because the people who are leading the investigation knows very well the environment, the application, and the framework that they are using. But we are definitely always following this path. So today, the idea is to focus on GC issues. And so I will show you how to get your metrics, how to get your numbers, and numbers that you can trust, how you would use them to start the investigation. I will dig into the implementation details, some internals of .NET Core, and then Conrad will show you a few. I think you have two demos, I think, and these two demos you will see other tools that I won't show you. So the idea is some internals, some tooling, but also some code that will allow you to get inside the features yourself, not only relying on tooling. So the beginning, the numbers. You know that when you are doing some .NET application, you are based on two different frameworks now. You have the .NET framework and you have .NET Core. And these two are different beasts, and they don't provide the same numbers by the same way. So if you think about the past, so let's say .NET framework, then you have to rely on performance counters. And I have put on that slide the usual performance counters that you are looking at when you get some problem with your application. I will take the example of Criteo and the server application that we are building and running in a production. Most of these applications, what they have to do, they have to process request as fast as possible. So the usual metrics that the application owners are looking at are what we call business metrics, and one of the most important one is the duration of the request processing. And if we see an increase in that processing duration, we might have some problem because we have SLAs to process the request, and so most of the issue that we are trying to solve are when the duration increase beyond that SLA. So the numbers, the metrics we are looking at are the metric that could explain this kind of increase. So for example, here you will have the number of exceptions per second. We had some issues with applications that were throwing and catching tens of thousands of exceptions per minute, hundreds of thousands of exceptions per minute. So you can imagine that this has an impact on the CPU consumption, but also in the time spent to process request. We also have highly multi-threaded code, so we need to avoid contention. Contention is when one thread tries to acquire a shared resource and another thread already adds a lock on that resource. So the second thread will have to wait. And so if you look at the performance counters on Windows, you are looking at the contention rate per second. It's interesting because it gives you the number of contention, but you don't really know the duration of the contention, which is the most important part for us when we need to figure out if one of the problem might come from multi-threaded code with locks and contention. And the rest, all that part is related to the garbage collector. So you can see that we are interested in the number of collections and the size of the different segments. Conrad has explained a lot about the interval, and I think the next one next week will be about generation. But you know that the objects end up in one of these generation, and this could be the place where we have to look at if the large objective is too big or some stuff. And I will show you some graphs where this is more obvious. And the last one is also something interesting. It's the number of survivor of finalization. This is the number of instance of classes that implements finalizers. And if you have a large number of finalizers, it might end up increasing the duration, the lifetime of some objects in memory, and could increase artificially the amount of memory that is consumed. So this is the kind of information that you are looking at. It's obviously only for Windows, because it's from the performance context from Windows. But more important, it's only for the .NET framework. What I mean is, if you are running an application on .NET Core and not on the .NET framework, you will get 0 performance counters, because obviously the .NET Core is supposed to work on Mac, Linux, and Windows. So the performance counters are not a solution.
Even if you are running it on Windows, right? So
exactly,
it may be a little bit surprising that even if you are using Windows, performance counters are not there. And it was pretty surprising for many, because we have used these counters for so many years, and out of a sudden there were none, and it was pretty sad moment, like where are our performance counters?
Yeah, how would we be able to get the same level of information? And we had to rely on different numbers. And I want to show you the kind of dashboard that at Criteo we are building. Again, remember that we have business dashboards with metrics relying that shows the health of the application. And when a problem happens, we go down to figure out if the runtime could provide a reason of the problem that we are facing. Again, the increase of the processing of a request is a good example to keep in mind. So here, I want to show you the numbers that we are gathering, and I will show you how to get this number yourself. And that's one of the goal of this presentation. So it's not only to show you something fancy, you will be able to get exactly the same numbers yourself. So if we look at that board, we have different graphs. The one that are important are mostly the number of compacting Gen 2. As Conrad explained, when you have a compacting Gen 2, the size of the Gen 2 make the time during which the frames of your applications are paused larger. So if you see this kind of peak here, it means that we had, at that time at 6 p.m., we had one compacted Gen 2. So we can rely that period in time during the day to some problem that has been detected in the application. You also can make the relation between that compacting Gen 2 with the difference in size of the generation 2 and also in the large object heap. So we try to make relations between the different numbers. Yeah, go ahead, Conrad.
So it is, I mean, I really like this dashboard. It looks very professional and it looks like a lot of information that you can have. And do you also trigger any, someone needs to be watching all the time or you have any alerts or above thresholds or anything like that, so you can automate things?
Yeah, so we definitely have alert system.
Nice.
Yeah, go ahead.
Because it's super nice for diagnostics, for example. Yeah, sorry, we have a little bit delay,
No.
I'm shutting up and then continue.
Yes. No, this is a very good question. In addition to the dashboard, we also have some alerting system, but the alerting system are per application. So the metrics on which the alerts are based are the one from the business dashboards. We don't have specific alerts on these numbers because we are using them as investigation starting point, not as detecting that something weird is happening. We are trying to correlate some CLR events to problem that happened at the application level. So, as you said, it's a lot of information. And what I want to show you is that you don't have to look everywhere. You have to look at certain area. As I explained, the compacting Gen 2 are the ones that are the most obvious impact on the duration of the increase of the duration of the processing of a request, because during that large Gen 2 collections, the threads are paused and can't process the request. So we might get some timeout. That could be one of the reasons. We also measure the size of the collections, because we are running in containers, and we have limitation in terms of memory consumption. So if we have some out of memory problem, we can detect if it comes from the managed heap or from native third-party component that we might be using. Think also about problem of memory leaks. If we have memory leaks in .NET, the increase that we should see would be definitely around either the Gen 2 or the large object heap. So this would be also the area where we would look at if the problem that has been detected by the applications are out of memory. But we have other metrics that might not seem obvious as starting point of an investigation. The first one is the number of Gen 0 and the number of Gen 1. And you can see here that the number that you have on the left are the number of collection per minute. Remember, I told you that you need to trust the number that you are seeing. And so this is very important to understand that these numbers are per minute. So the number, okay, we have like around 150, 160. So it's about 300 garbage collections of generation 0 and generation 1 per minute. You have 60 seconds per minute. So you can start to see that we have like around 5 collections per second, which is not bad. So now, if we think about what could be the cost of this high number of generation, and the important word in my question is high number. The thing that you have to really understand when you are doing an investigation is that you need to know the normal value of the metrics you are looking at. Because when I joined Criteo, some of the number I've seen, like the number of collection, for me were just insane. Like 300 collection per minute. It's like, what are we doing? Is it something expecting? And yes, it's something expected. And it's also expected on the size of the server that we are using. We have a lot of people working on defining the sizing of the machine that we need to use and defining also the limitation of the containers. And this is why it's very important to know the numbers to detect when the number changes. And why am I telling you that? Because we lately had an example about that. We had a change in the number of garbage collection by a factor of 10. We had 10 times more garbage collection, Gen 0 and Gen 1. And it was due to the usage of a new kind of server, brand new server, larger server with much more memory than we used to have. And we were unlucky because there was a bug in the .NET framework. It was some Windows server. And the bug was was in the computation of the size of the budget of the Gen 0. I don't want to dig into the detail because this is Conrad area, but just to give you the context, on this server, we get 10 times more garbage collection. So it means that we spent almost 10 times more in the GC, and we also use a much more number of CPUs on the server. So the CPU usage went crazy on the server, and we had to investigate this situation.
So super nice
Last,
scenario, because you know your normal value and then you migrate it to a new hardware, and then out of the sudden you see that you are far away from your baseline, so you expect
yes,
that something is really wrong. So measuring gives you this information. Without that you don't have anything, any context to
exactly.
compare.
Yeah,
Yeah,
you
that's nice.
you always need to have a baseline, a reference. If you don't have that, you're just guessing from nowhere. And the last part, the last graph that is interesting is this one, the last one, the suspension time during GC. So if you look at the number on the left, I'm counting seconds per minute. Always, it's always per minute on these graphs of that board. So it means that at some times we were spending 5 seconds per minute during which our threads were paused. So the suspension time here means two things. It's the sum of the duration of the pause time during which the GC does its work, and also the time spent by the execution engine to suspend the thread. Remember that Conrad explained during his internal presentation that the GC, when it needs to do some tricky work during which the thread should not run, it asks the execution engine to suspend the thread. Then it does the work, and it asks the execution engine to resume the application threads. So that number counts the free duration. So it's the sum of the free duration for each and every garbage collection. So here we are talking about 5 seconds, but 5 seconds for 300 garbage collections. So the real suspension time for each garbage collection is much smaller than that.
And because you mentioned a few times that I'm explaining something regarding the GC, I'm just copy pasting the link to the playlist to my .NET GC internal series, because
Perfect.
maybe not everyone is aware of this. So this series which you are referring to is a really deep knowledge that I'm not always having time to talk about in my various activities. So I imagined, okay, let's make it so deep as possible and dedicate a separate series of webinars for that. So if you are interested in the deep internals of the GC, how it is implemented, this is the series for you. And thank you, Chris, for mentioning that.
No, it's
Okay,
definitely
sorry for this
very
interruption.
Yeah, it's definitely a very valuable source of information about how the GC is working, and it's free. So just watch them when you have time. It's good. And if you could be watching this webinar, it's almost every Wednesday except yesterday. You could also ask the question that you want. So it's very, very nice. Thank you for that, Conrad. So here I've shown you the different metric that we are using to start an investigation for information related to the garbage collector. But we also have a second area, and I won't spend as much time as for the GC because the topic of today is the GC. But again, think about the possible reason of increase of request processing. I already mentioned the thread contention. So it's the number of time the threads had to wait. And we had this information in the performance counters. But what we didn't have was the duration of the contention. And here, I will show you how to compute that duration. And this is much more important for us because if we see large spike over there and only spike here we don't really care. These one are the one that has an impact on the request processing duration. It's also important to have the number of threads, because if you have 10 threads and you see that number of contention, it might be a problem. But when you have like 100 or 175 threads, having 50 or 25 contention per minute, again, remember, it's like almost nothing. We also deal with exceptions, and we try to define buckets. We have the critical exceptions, the one from the applications, the one from the systems, and the one from our own SDK. And so that way, if we have some exceptions happening, we are able to figure out where the exceptions were thrown, in which part of the code, and see if we could start an investigation on that. Something very important about exceptions is the fact that it's not always obvious to know if it's the cause of a problem or a consequence of the problem. Let's take an example. If we have a large number of compacted Gen 2, it means that we will have the duration during which the application thread will be suspended, will be paused, which will be longer. So we will have more timeouts in terms of request processing. And think about clients calling servers, and they also have timeouts. So they might close the socket. It means that in the server, when the GC resumes and your threads continue to work, they might try to read from the socket to get information from the request, or to write into the response, and the socket will be closed. So that would explain why sometimes you might have some socket exceptions or operation constant exception in terms of timeout. And so that's why it's also important to know what could be the reason of the exceptions. So here you have an ID.
That's super scenario when super nice scenario when you see socket exceptions, so you immediately would be interested in, I don't know, investigating TCP connection problems or anything related to network, but it is caused by the GC, something from totally different part of the runtime. So it is so it is really nice to have all these measurements that you are showing. Sure.
Yes.
Not to concentrate on a single point. That's very nice.
Yeah. The example that we are using today about
internet issues, unfortunately.
Okay. I hope that everyone is still hearing us. Should I continue, Conrad? Do you hear me, Conrad? Wow. I feel alone. I hope that everyone is hearing me. So let's continue, at least on that part. I want to jump on what Conrad just said. Even if that presentation is about GC, when you start an investigation, don't rush into specific IDs. Always start with the numbers, look at the numbers, and maybe it's a GC issue, or maybe it's a thread contention issue, maybe it's exception issue, maybe it's something else. And don't jump to direct ID like this. Really look at your numbers, look at your metrics, and even before that, look at your logs. You should always start with the high-level information that you get. You might get some information in the logs where the timeouts are stored and listed, and so the logs is a very important part of an investigation. But today I will focus on the metrics, and especially on the GC metrics. Should I continue, Conrad? You think that we are still online? Okay, so I don't get any answer from Conrad, so I will continue. So the next step, once you get all this information, is how would you get this information? So let's start now from the implementation perspective. How are we building these nice graphs? Well, we have to collect the information. And how do we collect the information? We are using events that are sent by the CLR. There is a system that allows the CLR, the CLR to emit events through the entire machine. And on Windows, it's called ETW, for Event Tracing for Windows. It's a system-wide architecture, kernel-based architecture, very, very efficient, that allows any application to activate some providers. Here we have different providers, nameless, but usually the one that we are using are the .NET provider. We are also using the kernel provider to get call stacks for examples. And this provider will emit events through ETW, and it will go through sessions. These sessions are system-wide, so it means that if you are writing a tool to listen to these events, you will get even for all the application that have the provider that you are enabling. You have two situations. You can have a runtime tool that listen as the events are flooding out of your application, or you can ask ETW to generate a file, and you can analyze the file with tool like a Purview, for example. So this is the kind of pipe from which you can get the events. So what is interesting is the fact that for the .NET provider, Microsoft is pushing the documentation to you. And so you have the list of the different events that are sent. You can see here that, let's make it a little bit bigger. You can have a lot of information and categories of event. You can have contention event, and you can have garbage collection event. These are the events that we will focus today. So if we go there, the next step is to think about what you can do for .NET Core, because here I mentioned Windows, I mentioned ETW, and so what is the difference between .NET Framework and .NET Core? Unlike performance counters that are working only for the .NET Framework, these CLR events are emitted both for .NET Core and .NET Framework. The only difference is that for .NET Core, you want to get this event on Linux. So there has to be another pipe through which you get the information. And this is what this slide tries to show you. On the CLR side, so in the application, the CLR is creating a specific diagnostic server thread, and that thread is listening and reading and writing to what is called an event pipe. So this is the name of the Microsoft technology. Behind that event pipe, you have two different implementations. One for Windows, which is based on NemPipe, and one on Linux, which is based on a domain socket. And on the other side of the pipe, you will have any monitoring tool. And all the CLI.NET Dash tool, like .NET Trace or .NET Counters, they all rely on this event pipe mechanism. And I want to show you one tiny implementation detail. I mentioned here that on Windows, it's based on NemPipe. And this is how the CLI tooling knows the list of the .NET Core application it can listen to, because the main difference between .NET Framework and ETW and the event pipe is the fact that ETW works for the whole process on the machine, but the event pipe, you have to connect your monitoring tool to one specific process, only one. So if we look at the NemPipe, thanks to the Windows Object Explorer tool, it's a free tool that you can download. You just look at the pipe and you look for .NET. And if you look at, let's zoom it a little bit. If you look here, we have three different .NET dash diagnostic dash 13660. These are the PIDs of the process that are running .NET Core. And this is how the CLI tools knows which tool they could attach. And that's the reason and what I wanted to show you that, because if you have some problem with the CLI tool, you can ensure that the application have well registered their event pipe with this tool. Okay, so now we know that we can get some event. We know through which mechanism, ETW or EventPipe, but the most important part is what kind of information can we get from these events. And these events are based on a well-defined description of all the event through that CLR ETW all.man file. It's from the implementation of the core CLR, but it's the same with the .NET framework. So if you look at that file, it's over there. It's an XML file with a lot of information. And from one of these information, so for example, I've used the exception event, which is the one that we are using to get the name of the exceptions that are thrown and caught in an application. You can see the definition of the payload. So the payload, we have the type of the exception as a string, and we have the message of the exception as a string, and other information that we are not using. So it means that if you receive this event, you are able to get the type of the exception and even the message of the exceptions. So all the events are, not all the events, but a lot of events are documented in the docs, the MS docs. And if you look at the exception, for example, you will find the same information as we have in that file. Why did I show you that specific file? Because some of the events are just not documented. And so if you want to know the information that you can extract, you need to go down to this file. But yes,
I'm back. I hope so. Sorry for the problems. I
Yes.
was disconnected, but the stream is live all the time. So if something
Okay.
such a bad thing will happen again, just sorry for that. I have a question regarding these events because we have LTTNG and ATW events as a communication protocols, right?
Yes.
And this definition that you have shown is shared between them, right? So this is the same format for both mechanisms, right?
It's not the same format, but it's the same payload.
Yeah, exactly.
So
same
yes,
payload.
yes. So it's the same content. You will have the same information, but it's not packaged the same way. But we don't have to really care about that, because I will show you that we have some libraries, some nuggets that will do the job for us. We just get the fields of the payload as properties that we can get.
Awesome. I have one question, but unfortunately was disconnected because you have shown this pretty nice dashboards. I'm not sure because I was disconnected. If you mentioned what you are using for configuring all this stuff, like we don't have something like that out of the box. We have events being generated,
Yes.
but then we need to produce those dashboards. So could you say a few words about what tools do you use for that?
Yeah, that's a good question, and I didn't mention that. So we are using Grafana. Grafana is the site that provides these nice boards with the graphs, and we are using Graphite, which is the database upon which Grafana will extract the metrics that will be displayed. So our job is mostly to export the metrics into Graphite or also Prometheus. We have the two solutions. We can push the metrics into Graphite, but we are now changing to do the opposite. We have Prometheus that will scrap the metrics from a companion, a sidecar application that exposes the metrics. So we have a push and a pull mechanism to get the metrics inside Grafana. But I think that you could do the same for your own monitoring pipeline. But this one is the one that we are using. Thanks for the question, Conrad.
Thank you. And one more thing, if you have questions, do not hesitate to interrupt Chris or me, because we really like questions, right? This kind of interaction from you, and that information that you are not sleeping, for example. So
Yes, for example. Okay, so we saw the metrics, we saw the pipe, we saw that we can get the definition of these events, and you can imagine that the CLR is exporting a lot of events. Here you can see that the file is just huge. We're talking about how many? 7,000 lines, not only for each event, but here you can see the list of the events. We have like hundreds of different events, and you can imagine that, for example, for the GC, if we have hundreds of GC per minute, like I mentioned, something like 5 per second, we get a lot of message, not only one message to explain that, oh, there was just one GC at that time. So we might have a lot of message that could be emitted by the CLR, and we don't want to impact the performance of the application, because remember, I'm talking about a .NET application, a CLR running inside the application, and the CLR will generate event in C++, will write the payload and send the payload through an MPipe or through a socket. So this has a cost, and so you need to balance the two. Microsoft has done a lot of work to minimize the impact of this event, and one of the first thing is to avoid generating these events. So all these events are sorted by category. These categories are called keyword, and you can also define a level of verbosity. So when you are interested in an event, if I'm going back to the implementation documentation, you see here at the top that that specific event as a keyword, so it's part of a category. So if you just want that specific event, you just have to tell the GC, I just want the event from the exception keyword, and I need the verbosity level of warning. So all the events that are not from that keyword, for example, the GC event won't be generated, and the one with a verbosity level that is, or you can imagine lower or higher, won't be generated neither. So we looked at the events we were interested in, and I think we have 6 or 7 events. And so we tune the keyword and the verbosity level to get only the event that we want. I will show you how to do that. Last but not least, you could use these events to better understand how the CLR is working. If you are like Conrad or like me, who want to understand how the CLR is working, you need to git clone the runtime repository and look at this huge amount of C and C++ code, and it's complicated because it's very, very large. And a hint, a tip that I can give you is the fact that this specific clrEventManager file gets compiled during the GC compilation, and it will generate a number of helpers functions for the CLR to call to emit each and every event. And these functions are prefixed by the fire etw, and then you get the name of the event after. So it means that if you search inside the code of the CLR for fire etw, you will get the list of the area in the code where the events are triggered. So it will help you if you want to understand how the threading works and how the lock-in could happen. Then you just have to look for the dedicated fire etw event. And so that way you go directly to the file where you can find the information. That's something that is really helpful. At least it helped me for the GC, for the exceptions, for the contentions, and it was very, very helpful. It saved a lot of time. And I want to also mention that Conrad will show you how to collect this event with some tooling, but what I want to show you now is how to do it yourself, writing C# code. So how would you listen, either through EventPipe or ETW, to these events? Well, it's easy. You just have to get the trace event NuGet package. This is a NuGet package provided by Microsoft, and it's also an open source project because it's part of Purview. And Purview is an open source project, so if you are interested in the implementation detail, you can get the source code of trace event. And if you find some bugs, you can push a pull request and discuss with Microsoft to get the problem fixed. So this trace event NuGet package, what it does, it gives you access to the ETW trace event source type. This type map the source, so it's like a CLR. You can see all the event coming from the applications. And the next step is to listen to these events. So the source has a few properties called trace event parser. You have one for the CLR, which is the one for .NET. You have one for the kernel provider that I mentioned. You also have one which is called dynamic. If you want to listen to any kind of event and you want to by hand extract the information from the payload, you can do that. But today I will focus on the CLR one because this is the one that you will need for the GC event. So let's see some code because it's good to have PowerPoint slides, theory, high-level view, internals, but we are developers. And what I want to show you is some C# code. So remember, I want to listen to events. So before showing the code, always showing what you want to achieve. On the left, you have a simulator application, which is a .NET application. And this application is allowing me to trigger garbage collection or to allocate some memory. And on the right, it's a simple console listener that will listen to the event coming from that application. So here, if I'm triggering on the left a Gen 0 collection, I'm just typing 0, and I'm expecting to see on the right, let's make it a little bit bigger. Yes, something like this, like this. So here I can see that I got a garbage collection of generation 0. It's the 26 collections, and you get the suspension time. You see if it was compacting or not, and you get the size of the Gen 0 here, the size of the Gen 1, size of the Gen 2, the size of the large object heap. And we also get some information about what kind of garbage collection it was. Here, the name induce means that I called in my simulator the gc.collect. So it's like by code. It's induced by my own code. But if I'm starting a Gen 2, for example, I should see the difference here. I get 2 here, so I know that it's a generation 2, and again, having the same information. And if I'm starting to allocate randomly, I should see some garbage collection happening over there. You see that the reason is a little bit different, and you can see, if I'm lucky, I should get some Gen 2. Let's stop the actions over there. And here, you can see that we get some Gen 2. It was a background GC, and the reason why, because we asked for allocation, and the GC didn't find enough room for that small allocation, so it triggered the GC. You see that we have all the information that we need to fill up our monitoring pipeline. So let's go into the code now. What I need to do, I need to create a session. Remember, either with ETW or with the EventPipe, the representation of the source is a session. So I need to create a trace event session object, and I give it a name. Why is it important to give a name? Because especially for ETW, when you are doing some debug, you might stop the debugging while you are processing the event from the session, and the session will be a ghost ETW session, and you might want to close that session, and you need to have the name for that. So you give it a name, and then here I'm creating a new thread. In the thread, I'm registering the event handler corresponding to the events I'm interested in. I will show you the details in a moment. And then I'm calling that function called process event. This function is a blocking function. What it means that when the thread is calling process event, the process event won't return until the session gets disposed. So here I'm in a kind of deadlock, because if I want to listen and I want to stop, I need to dispose. So that's why I'm creating another thread to listen to these events. And so when the user, myself, just press enter, I will be able to exit the using and so dispose the session. And in the additional thread, this function will exit, and so we'll be able to stop the processing. So I have wrapped the event processing inside a dedicated class called the clrEventManager. And so I need to look at the implementation. When I'm calling the process event corresponding to that specific function, what I'm doing, I'm setting up the communication to detail what kind of provider I want to enable. In my specific case, I'm just interested in the CLR provider, and they are identified by GUID. And trace event expose a large number of providers and give the corresponding GUID. Then you need to define the list of the keywords you are interested in. In my case, I'm interested in the contention, the threading, the exceptions, and the GC. Here you will see that I need a few keywords, because you will see that I need a few events from different keywords to get the information. And once this is done, I need to set the verbosity level. And since I know that for that specific event, I need the verbosity level verbose, I made the difference between the informational that sends less event than the verbose level. And once this is done, then I can call the process function on the source, the CLR source from the trace event session. So you see, it's quite simple. And when you register your event, let's look at what we are doing. Depending on the kind of filter I have given to my clrEventManager, I'm just registering my event handler like a normal C# event. And the trace event library, the trace event nugget, will do all the magic to listen either on ETW or through the EventPipe or even LTTNG, get the event, extract the payload, and transform this payload inside a normal C# object. So if I'm looking at the exception, for example, you will see that you get a strongly typed object, exception from the type exception trace data, and you can extract the information you want. Remember, we get the exception message and the exception type. So it's really, really simple to get this information. What is a little bit more complicated is to just know which event you have to listen to. And to get that information, you can look at the documentation, or you can just read the blog post that I have written that explain for all these situations what are the events you need to listen to, and also what information to extract from them. So you get this blog post. You also get the source code. So the source code I'm showing you today is available from my GitHub repo, and you will have the link to the repo at the end of the presentation in the slide, and we will share the slide. So maybe I think I'm done over there with the source code. So if you have any question about this implementation to get the metrics, please ask them, and Conrad will see if we get some question. So Conrad, do we get any question at that point? Okay, so I don't get any feedback even from Conrad. So I hope he doesn't have some connection problem. So here the code I've shown you is the scenario where you want to have a sidecar application. So it's an application that is listening to the events. Remember in my diagram over there, this is the situation where I have a sidecar application that is listening to the event sent by the CLR provider. But you have another scenario. And the other scenario is, let's say that instead of doing this, having a monitoring tool that is running aside, you want to internally, in your own application, you want to monitor this information. So what you have to do is also very simple. You have to create a type that derives from EventListener. Once you've done that, you kind of register your type, the instance of your type. So here in my example, I have written a GC EventListener type, and that type, what it will do, it will kind of build a GC log. In Java, you have some feature that allows you to tell the runtime, the Java runtime, to generate some events that are related to GC in order to analyze them through some GC log files. And I try to mimic that with .NET because you don't have that specific feature in .NET. And in order to do that, I define that type that inherit from the event listener. And once you've done that and you create an instance of that type, the CLR, because remember, we are running inside an application that is managed by the CLR, you create such an instance of such type. So the CLR knows it. And so it knows that it needs to call you in different times. First, it needs to call you to tell you, hey, you know what? Here are the source that I have available for you. I can give you information about the CLR. I can give you information about ASP.NET Core. I can give you information about other parts of the CLR. And so to get this information, your own event source created override gets called by the CLR at the beginning of the application. And you get the information, which is the name of the source. And so I know the name of the .NET runtime provider, which is this one. And so when I get called for that specific event source, I'm telling the source, please enable the events, meaning that I want to receive the event, and we pass the same information. Remember, I need to pass the keyword to only filter the event I'm interested in. Here, in that case, I just want the event from the GC. Nothing about exceptions, nothing about all the stuff that I've shown you earlier. And I'm giving the verbosity level that I need for the event I'm interested in. Once this is done, the CLR start to send you the event through the on-event return override. So that function will be called each time the GC emit an event. And so what you have to do, you have to know the ID of the event you are interested in. And this ID is provided by the documentation. So you have the ID of the event. And if you look at the GC, you will have for each and every event, again, the keyword, the level, and the ID of the event. So here, it's a little bit more complicated because we are not relying on trace event. We will have to know the ID of the event, and we will have to know what's inside the payload of the event. So if we look at here, we know that when I'm receiving that specific event, it means that a new GC started, and I know that I need to clear the information for the current GC. And so here we can see the implementation of all the different events that I'm receiving and the data that I will be extracting. I don't want to dig into the details because Conrad will do that. And just to show you that if you want to listen in proc, again, create a type that's derived from EventListener, enable the source that you want to get the message from, and process the event you want from the on-event return. That's very, very simple. You again need to know which event to listen to and which property of the event payload you want to process. One tiny detail, and this is a true story. Last week, we get some bug at Criteo because we had this kind of implementation, and we got some null reference exceptions. And the code that was crashing was the code inside the on-event return. And it was very, very weird. We had to do an investigation. One of my colleagues, Eugene, did the investigation and figured out that, in fact, the problem is that the CLR, when the GC event lister object is created, remember you have a constructor. So in our constructor, we were passing information like the pipe to send the metrics to our internal system. So we pass it to the constructor, but the implementation of the CLR, meaning the event listener type, is called before our own code of our own constructor. And guess what? If you get event at that time, then the on-event source creating code will be executed, and the on-event return code will be executed before your constructor gets executed. It's a very interesting story. Eugene published an article on Medium. It should be available soon. So just look at Twitter, and you will see when it will be published. So you will get all the details. I think I'm done now, and I can come back to that part. Do we have question about the implementation details?
I'm not sure, Chris, if you are hearing me currently or not, because my internet is going crazy. I'm trying to troubleshoot internet during the troubleshooting GC webinar. It is
poor Conrad.
I'm not super happy. We have one question. I will try to show it while the internet is on.
Up.
One question from...
Yeah, so it's what the difference between ETW, EventPipe, and LTTNG. So if you go back there, let's go back here. So if you are running a .NET Framework application, the event will go through ETW only. If you are running a .NET Core application on Windows, it will go through ETW and through EventPipe, and even in proc, as I showed you just right now. Now, if you are running on Linux, you won't have ETW. So on Linux, the corresponding kernel-based mechanism is called LTTNG. So the .NET Core implementation of the CLR is pushing the CLR event. The same. Think about what the CLR is doing. Let's say there is some exception. So the CLR is getting the information that there is an exception that has been thrown. It computes the name of the type, the message, and all the information. It builds the payload for the event, and then it sends the event on a different channel. On Windows, I said it will be ETW or EventPipe. On Linux, it will be LTTNG and EventPipe. So it's really the communication mechanism that is used, which is different, but the generation of the event is the same. Is it
awesome? I have internet once again, so trying to show another question.
Okay, let's look at the second question.
That was, I believe was, and in that time,
Okay,
you
so
can, Max, you can say whether the answer was good or not for you.
Okay, so the second question from Thiago is that 2 years ago, he developed a custom provider in order to collect business metrics, which is great. So what is your thought about it? It's very good to implement your own provider because it means that you could use the same mechanism to aggregate all your metrics, and so that's very good. You need to again think about the performance impact of your provider. If your business metrics require a lot of processing, then you need to think about that. But internally, we have our own system that is doing that. You can see also that the CLR itself from .NET Core 2.2 to 3 to 3.1 to 5 adds more providers. And also in ASP.NET Core, for example, you can use the ASP.NET Core new provider to get information. So my thoughts are, go there. It's very simple to implement, and it allows you to aggregate all the different metrics through one single pipeline. So it's a win-win.
My favorite question, the next one.
Okay, so let's be clear. There is, I think, I don't remember if this one, I think this one, the Pro.NET Performance is discussing the
it is good. It is
ETW.
very good. Sasha,
I think this one, yes, classical one. So I would look at this one.
And CLR.
Do you have other answer?
CLR via C#.
No. I don't think this one explain ETW.
I
don't think so.
CLR via C#? No, maybe not. I don't recall it. So
no, I don't think so. You mean this one?
Yeah, exactly.
Yeah. I have a library on my side.
You have all the books.
No, but to really answer your question, I don't think you will find books describing especially ETW. I think the one that I've shown, the one from Sasha, might
especially in the context of .NET, right?
Yes, I think this one is also explaining that part, if I remember well, at the end. You have a section.
Oh, yeah. Sebastian is also saying that it has a chapter about it.
Yeah. So yes, Sebastian will detail that a lot. If you need to get information about what I've shown you, my blog post should help, because you have, I think, everything you need, both in terms of implementation and description of the event. What else? I think that's pretty much it. Oh yes, and if you need more details about the event themselves for the GC, you know which one you need. It's a little bit heavy, but this one is nice also. Yeah.
Maybe enough.
Yeah, maybe. So
and next question, while I have...
I get another question.
Is the one I'm trying to show.
Yes, that's a very, very good question. Thank you very much, Max. So you mentioned your question is very good. It's like, are EventPipes
today with this?
Are EventPipes and ETW APIs the same? And that's a very good question, because you've seen that here I have an adhesive for ETW. So the answer is yes, there is a difference in terms of session. So if we look at the different implementation, here you can see that I have to create a trace event session for ETW. And this is completely different for the event pipe. For the event pipe, I don't have to do that. I just have to pass the process ID, And in the clrEventManager, this is where the code changes. I need to use an EventPipe client, and that event pipeline, because remember, we don't have a session like machine-wide, we just have a direct connection to one specific process. So you call the collect tracing from the EventPipe client class, you pass the process ID, a few configuration, but like some internal implementation, the kind of format you are interested in, plus the list of the provider. Once you've done that, you get a session ID, and from the binary reader, which is returned by the collect tracing, you create an EventPipe event source. And from that time, these type implement the same interface as this user session.source. So only the bootstrap to do the connection is different, but the rest, and when I mean the rest, I mean the code to set the listener, to set the keyword, is exactly the same. So if I'm looking at process EventPipe event, you see, I'm registering the event. It's the same code as this one, because the type EventPipe event source is the same, implement the same interface as the one from ETW. They've tried to make the API not that complicated to use. Great question, by the way. Is it answering your question, Max? I hope so. I don't see Conrad moving, but I see the message coming up and down. Yes, so another answer about a good book is this one. And I don't remember if you will find some details about the purview, yes, you get ETW event. You're right. You have a section about performance counters, and you have a section about ETW event, and create your own ETW event listener, and so on, plus purview. So thank you for that. That's also a good source of information. Any other question? I don't see Conrad pushing questions, so I guess he still have some problem. Okay, so I can see the questions. Okay, so let's see if I can have. So I see the question. I won't be able to show you the question because only Conrad managed that. So I get the question from Max. I get the writing performance.net from Asbrainiac. And I get one from Kevin. Hi, good evening, Kevin. So is it a game where we try to find a book Christophe doesn't own? That would be a good game, but you have to, yeah, that could be a good game. Thank you for the question, Kevin. So I don't see any other question. So let's go back to the presentation. Unfortunately, we are at the time of the presentation where Conrad was supposed to continue. So the next step will be obviously, okay, I've shown you some code, I've shown you very quickly some event, but it would be interesting to get the real internals and the details of each and every event to process the information. So you have two solutions. First, you are Conrad Kokoza and you have everything in your head. And that's why I've just copied an extract of his book where he describes all the different events that happens during a garbage collection. And I'm pretty sure only Conrad and knows, and maybe Maoni, what are the details and the payload of each and every event. Or you could you could go to the source code, look at the implementation, and this is the summary of the main events. You will find them also in some of my blog posts, but I was expecting that Konrad could continue at that point. Oh, I see you are back, Konrad. So can you continue on your side? I can see Konrad, but I'm not sure he's hearing us. Too bad for that. So just wait a moment. I will switch screen so you will see not my face anymore. I will try to contact Konrad directly. And see if he can continue. Let's see. I don't see him moving on the screen. So so too bad for that. Okay, so what I want to do while Konrad is trying to reconnect is detailing some of the event. One of the two scenarios that we wanted to describe today with Konrad, and Konrad is supposed to do the yeah, I need to start my best Konrad imitation. It will be complicated. So the idea was to show you two scenarios and how to investigate two scenarios with Purview. But before that, to show you the event that will be used during this investigation. And so I will go to this first investigation that we had to face, and Kevin knew this kind of problem where we had what we call noisy neighbor. Sorry, I see a question in the log. Is LTTNG widely available on Linux distress? I don't know, but it seems to be available. I think so. Yes, we used it in our own distribution, and we found it on many distributions. So so you could use it. I would not recommend to use it. Mostly because Microsoft is investing a lot in the EventPipes, and the optimization that Microsoft is writing today will be on the EventPipe channel of communication. So I would recommend that that you select EventPipes rather than LTTNG. And I see that Sebastian is telling the same thing. It's generally available, but he would recommend to use EventPipes. And Kevin says the same thing. So good. We have a question about as Brain Maniac. So is there any diagnostic expert course starting, and when? So I don't have the answer for that. So if Konrad is back,
maybe
Konrad is back.
I'm back.
Konrad is back online. Yes.
Oh, I have one minute window again.
Go ahead,
Konrad. Like it is absolutely crazy. So first of all, while still online, I think we are over 1 hour and my internet is just dying all the time, so we don't have time for demo today. We will make I will make this demo during the separate webinar maybe next week, because it doesn't make sense to try to show anything from my side today. So the demo about the suspension times will be next week. Regarding diagnostic course, yes, we are opening it next week simply, so stay tuned. If you maybe I will start sharing the screen, maybe I will be able to do that. And will not kill, and it will not kill.
I will stop sharing.
Anything.
Yes, so
okay, so we have stopped at this slide, right?
The one before, but yeah.
Okay,
Go
so the
ahead.
suspension time demo will be next week, because it is nice to see how you can diagnose those spikes and try to understand where are the pauses coming from in case of the GC. And what, by the way, it is almost the last slide. So we have resources, and mostly what is interesting for you, I believe, is the source code of the examples that Chris was using today. So we will be just adding those slides, those links under the video today. This is the repository with all the examples, with the simulator, with the tool that is able to listen to the events. So this is the main repository for today, as for me and probably for you. And also the blog from the Chris, and also the trace event by itself, which is open sourced, and there we have an examples how you can use it, right, Chris?
Yeah. Yes.
And yes, the link to the .NET GC internals recordings, which is, as we mentioned about .NET GC internals, the whole source code of the core CLR, which is always welcome to be read. It is pretty a lot of code to be read, but still a lot of very nice information. And regarding the course, if you have any question, this is now perfect time to ask any additional questions, because we are slowly ending, not to keep you too long for today. As mentioned, next week I will organize the webinar with these demos that I wanted to present today, so nothing be lost. And regarding this course, diagnosticexpert.com is the site when we are hosting our course, where Sebastian is the trainer, and we have Chris as a mentor, also Kevin, which is today online, and the Pavel, which is not online, but maybe we will be watching this video. So hello, Pavel. And we are opening this course to next week, and this is much more than only GC diagnostic. Like Sebastian is presenting you a lot of stuff regarding TCP, deadlocks and threading, and how you can also use tools at the level of to understand the whole environment, the whole operating system, everything in the context of .NET, but from various perspectives. So you will be able to understand, for example, what the symbols are, how you can configure symbols, and also some parts are covering GC. So if you like it interesting, it is the course for you. I believe every .NET developer should be interested in that course, because every one of us is just diagnosing things, like it is our everyday life. So if you are interested, visit this site. It will be opened since Monday, and then you will be able to buy it only during the next week, because we are just having this opening windows. We are opening windows for sales, so only in the next week you will be able to buy it. And that's all about the course. And now it is time for you to have any questions. So if you have any questions, we are and I have internet for a moment, but it is, intermittent thing that I'm not happy
Let's
yet.
cross fingers.
For sure, as fast as I will start making a demo, it will be gone. So let's just not even try to do that today.
No.
And let's see whether we have any more questions then. Not yet. No questions. No. Sebastian,
Okay.
maybe you have any questions to our mentor, which will be kind of diagnostic expert mentoring online.
Oh yeah. I'm not sure Sebastian is really monitoring. It's more collaboration and exchanges.
And if not, because I'm seeing that my internet is again trying to die.
Oh yeah. So I see one last question.
Okay.
I see from Brainiac.
One question.
What
trying
tool
to
can
show it
one?
before my internet
Okay.
will go crazy?
Okay. Let's see if Conrad is able to show it or can read it. So So what tool can you recommend for debugging in kernel mode on Windows? It's too bad that Pavel is not here today with us. So do you have any answer, Conrad? I have one, which is
probably
obvious. WinDBG.
Exactly, and Sebastian, as I'm seeing, also is answering WinDBG. I remember once I was attending the Sebastian talks when he was using WinDBG to show how to debug.
What? I think we've lost you, Conrad. Wow. Yeah, so WinDBG is the official Windows kernel debugger. Inside WinDBG, you have a lot of extensions that allows you to access some kernel parts, and you should definitely go for WinDBG. I've seen someone like Alfred saying that KDB also. You have some console debugger that you could use, but if you could use WinDBG, I think in terms of UI, it's easier. Again, Brainiac mentioned that years ago the soft ice was a mega tool. Yes, I used soft ice and I debugged incredible stuff when Windows was exiting, but it was a long time ago. I don't think you could do that now. So yeah, I would go for WinDBG. You have a lot of presentation of WinDBG documentation, and I'm pretty sure that Sebastian will discuss in detail what you can do with WinDBG for sure. I get another question from Max. I think we've lost Conrad. So the question from Max is, can you explain the EventPipe event delivery mechanism a little? For example, how would it work on Linux? Yes, I think I've showed you that. Let's see if I can share my screen. Again, share the screen. Let's share that screen. Do you see my screen? I think, unfortunately, Conrad has to do something on his side. So, okay, I don't know if he's still hearing us, but you don't see my screen again. So if you remember, I had a slide where I showed you that on the left there was like a light blue monitored application, and on the right kind of purple monitoring tool, and between the two there was a name pipe on Windows and a domain socket on Linux. So your question, if it's about Linux, it's based on a domain socket. So the diagnostic server thread code inside the CLR is opening the domain socket, listening to the questions, to the request coming from the monitoring tool. And so it just listening to the domain socket. When it gets a packet from the monitoring tool, it just process it and send the response through the domain socket. It's very socket based, like most of the stuff on Linux. The packaging is the same with namepipe or domain sockets. It's really the way the packets are sent to the monitoring tool, and it's also something that is used by other mechanisms. So I will go a little bit beyond your question. Here I was talking about events, CLR event, quote, but if you think about the CLR counters, which are not the performance counters, but is the new counters for .NET Core only, they are using the EventPipes. They are using different messages with different formats, but they are going through the same thing. And you can also see the information coming from the monitoring tool. So if you have used .NET Dump is the tool that you could use on Linux to trigger the generation of a memory dump and analyze a memory dump. How it's working, it's when you want to trigger a memory dump, what it does, it sends a command through the domain socket to the diagnostic server thread inside the CLR saying, please trigger a memory dump of yourself. So the code inside the CLR, listening to the same domain socket, get the command, says, okay, I need to dump myself. So it knows where the create dump binary, which is installed with the CLR. So it starts a new process, create dump, giving its own process ID to dump itself. You would see it's a two-directional pipe through domain sockets on Linux. I hope I answered your question, maybe more than the question. I got a question from Sam asking, can you share the slide in the chat? Unfortunately, only Conrad can do anything in the chat. I got a question from Brainiac. So it's an inter-pipe communication. I don't know what you mean by inter-pipe communication, but it goes through namepipe on Windows, and I showed you with the tool how to see the name of the namepipe. And on Linux, it's a domain socket. So Conrad left a message in the chat saying, sorry, totally gone. So I fear that that we've really lost Conrad that time. Do we get other questions? Because I'm still able to see the comments, so I can still answer. It's 8:30, so maybe it's time to finish the presentation, the webinar. If we don't have more question, I think it's a good time to say bye. Thank you very much for attending that session. It's too bad that that Conrad had these communication issues, but anyway. Oh, I get another question from Amit. So namepipe versus domain socket can communicate to a process on the same machine. Is there any way to listen ETW from a different machine? That's a great question. So I don't think that you can do that. You can't listen to ETW event from another machine. Maybe Sebastian knows if there are a way, but I don't know a way to do that. That might make the difference between Linux and Windows. But from what I know, I don't think you can listen to ETW event from another machine. So I'm counting. Any other question? No more question? So again, thank you very much for attending this webinar. Thank you very much. Conrad mentioned that he will have another webinar. Maybe it will be with next week webinar about generation. I don't know how he's planning to do that, but you will get the end of that webinar, meaning the two demos and how to investigate these noisy neighbor kind of scenario, plus another one that Conrad prepared for you. He will have his next session next Wednesday about GC internals and the generation, the notion of generation and memory layout of what the GC is using. I think that's it for today. Thank you again, and see you soon. Bye bye, everyone.